Welcome back for another episode of the 5G Guys. I'm Wayne Smith, and I'm joined by my co-host, Dan McBall.
Hey, Wayne, everyone. Thanks for joining us again. This is our third episode in a multi-part series that we call the Lifecycle of a Cell Site. The first episode in the series, if you didn't listen, 2 episodes ago was how cellular networks are designed. And then the one after that we recorded before this one was how cellular networks are constructed or built. So today we're going to talk about probably the biggest phase in my experience is modifications and maintenance of the network. So working on existing sites. I know from my old company, I bet you 70-80% of the work we did, Wayne, was existing sites, maintaining them, fixing them, or making changes to an existing site. What do you guys see at Vertex?
Yeah, no, I agreed. The modification of the network is an ever ongoing living organism, if you would. We do tons of our projects that we manage are site modification projects. They could be anything from batteries to antennas to remote radio heads to just any other type of technology that rolls out and needs to be altered. And so I think it should be a good discussion. That's what's happening now, I think, out in the world. I mean, they are building a lot of new cell sites, though, not to distract from that, but the modification is crazy. I think, man, you did some numbers on it the other day, right? It's probably about close to 700,000 cell sites that have to be maintenance today in the world. So
Yeah, and in the US.
So jump in. Let's talk about maintenance. From our side of it, we're more on the capital side of building the network and new technology rollout, not as much about maintenance, but I know you got background with that.
Yeah, no, for sure. We had a lot of folks on our team that we get called on by the carriers to maintain the network. Maintenance kind of comes in a few different flavors. There's preventative maintenance. So, we might be helping the carriers to go out and do tests on the antennas and the coax to make sure that water hadn't gotten in them or there was no damage to them. There's a way that, you can do that. So we might help go out, once a year or so and do that type of work. Carriers will have some of their own folks, technicians that'll go out and run calibrations on the electronics, make sure it's all operating to spec and do that on a regular basis. It's funny, this weekend, a friend of mine, his neighborhood had a power outage. He sent me a text message. He's, "Hey, how come my cell phone still works even though there's a power outage? How come the cell site's still working?" Right? I said, "Well, because there's backup batteries or generators on them that keep them running when the power goes out." Well, they have to go maintain those as well. They have to go test those battery strings and make sure that the batteries are good, just like you do on your car, right? And maintain that. So I think preventative is probably the first area that it's not as huge, but it's definitely something that's done. Hey, real quick, a quick word of thanks to today's sponsor, Vertex Innovations. For over 17 years, Vertex has been building the nation's wireless and broadband networks. Providing project management, network engineering, and construction oversight are just some of the ways Vertex helps their clients. So if you're looking for more of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's VERTEX-US.com.
Well, let's break it down this way. I think it's a good way to do it. So the site itself and the physical attributes have a certain amount of maintenance every year to them. The roads, the fences, the protection, the building, all of that. And then break it down in that. Then how about explaining a little bit about the equipment side of it? Because all of these things operate for years, and the weatherproofing and how that's done and how that's redone over a period of time to make sure that they meet the specs would be a good way to look at it. So what do you think? Does that make sense?
Yeah, sure. So I kind of talked a little bit about some of that preventative stuff. I think the other thing that you have to remember is that, like you said, these sites have some sort of a compound, right? So there's just standard maintenance that you'd see in any property, right? Weed control, getting rid of pests and rodents and what have you, because they sometimes build nests in the equipment because it's nice and warm, right? Get rid of those boogers because they like to chew on wires and stuff. And then I think it starts getting into more specialized, and that's the bulk of it, right? The tower itself, for example, towers have to be maintained as a capital asset. They're written off over like 30 years. Like these things, they last a long time, but if they're not maintained, we talked in that last episode about safety policies, those organizations that keep workers safe. Well, TIA being one of those that we talked about, Telecommunications Infrastructure Association, they have a standard that says a tower has to be inspected every 3 to 5 years, depending on the type of tower it is. And that's stuff like corrosion, damage to the foundation. If it's a guy tower, inspecting the tension on the wires or the anchor bolts to make sure the anchor bolts aren't rusted. So, those physical things have to be done proactively. And there's other things like towers have lights on them, right? Sometimes if so that planes and aircraft don't hit them, and those lights have to be inspected, or if they go out, the light bulbs have to be replaced. There's climbing apparatus on the tower itself so that the workers can climb up and down safely. That has to be inspected and maintained and taken care of. So yeah, there's a lot of work that has to be done there just on the tower that crews get hired to go do that work.
You mentioned tower, and like last time when we talk about cell sites, 60+% on a rooftop. And so those type of mounting structures also have to be tested. Have maintenance on those just as important as a tower in itself, correct?
Yeah. And one thing that a rooftop has more so than a tower, and we talked about that in some prior episodes about how the FCC has RF safety guidelines that say, whether it's operating under the parameters that deem it to be safe for human exposure to the radio frequency waves. Well, on a rooftop, oftentimes there has to be barriers and signs that are posted, doors locked to prevent the general public from getting on the roof and getting near the antennas. So from a maintenance standpoint, you got to go out there once a year and inspect that. Are the signs there? Is the door locked by the landlord? If there's barriers in place, are they still in place? And if not, that stuff has to be maintained. So that's an example that a rooftop has, towers don't, from just a physical maintenance standpoint of the structure, right?
Yeah, wow. And when you think about it, I know that you mentioned maintenance. Does lightning strikes come into play? Because these a lot of times they stick out in the middle of nowhere. They're standing out by themselves, and even on a rooftop, they're extending a rooftop by 20, 30 feet. In some cases. So what about that?
Yeah, for sure. And that gets to kind of the other major part of maintenance, which is after the fact maintenance, right? When there's outages, there's damage, and lightning strikes for sure can happen. And I've seen lightning strikes where nothing happens because the grounding protection and the surge protection on the site is adequate, and the lightning strike's not bad and nothing happens. I've seen sites where, you remember the old Roadrunner cartoons where Wile E. Coyote would have like a stick of dynamite and it would blow up like a firecracker, like all peeled back like a banana. I've seen sites where they get hit by lightning and the antennas are just literally nothing left on the inside of them, and they look like that Wile E. Coyote cartoon, and all the antennas have to be replaced, or coax catching fire, or the electronics down below getting completely fried and have to get replaced. And that's got to be done like ASAP, right? Because that site's off the air. That kind of stuff happens. Not all the time, but it definitely happens.
A crazy stat I just read that from the CDC, and I don't know if I should quote them after the last couple of years. But anyway, there's 40 million lightning strikes every year in the U.S.
Wow.
So it's a bunch of lightning. Right.
That's a lot of lightning. Yeah.
And this equipment is sensitive. And I think, around cell site, and as we talked about construction, the grounding, to your point, and the lightning protection is a key piece of every one of these locations.
Mm-hmm. Vandalism is a big one too. When I was working as an engineer, South Carolina, Charleston area was one of my markets back in the day. And we had this cell site that was kind of in the country, had a microwave dish on it. That was our backhaul because we didn't have, copper. Nowadays it'd be fiber to the site. So we had a microwave dish, and it was by this like roadside bar that these bikers and stuff would go to on the weekends. I swear at least once a month, our microwave dish would go down. And every time it was because these guys were shooting at the dish with their guns and rifles on the weekend because it was like a target, right? So we'd have to go deal with that all the time. So what we did was we actually made a giant target and mounted it on the tower away from the coax somewhere else. And they started shooting at that instead of the dish, and the problem went away.
Wow. I thought for sure, you were going to talk, when you talked about vandalism, the amount of theft of copper.
Oh, that's a big one. Yeah.
Because it's taken like tons of sites off the air when someone's like, I need that grounding strap or I need that coax, and they just go in and ransack it. So if you're out there and you see the world and you see a cell site compound surrounded by concertina wire, chances are it's one of those sites that's been vandalized and theft of copper that's in the components.
Yeah, that's a good one. Copper theft has been a big problem forever in our industry.
Probably still is with, the price of copper on the market. And I think they've done a great job, the recyclers, of trying to notify the authorities when they find that kind of copper coming into one of their scrap yards and seeing it. Because it's just too, it's too unique today now that we're so far into it. But wow. So we got vandalism, we got theft on the cell site, we have normal maintenance from environmental weather, because weather can play havoc on any kind of outdoor structure. And so a lot of different things that require maintenance just from a maintenance perspective.
Right. We're kind of talking now about all the physical stuff, but the engineers have maintenance they have to do that's not really a physical thing, right? They do things like what's called drive testing.
Okay.
And what that is that's a regular cadence of going out in a vehicle that's got like autonomous computers and stuff that are making and receiving phone calls, text messages, data sessions, and it's being driven all over the network by a technician. And it is literally testing the network to see how the network's performing so that proactively problems can be found and the engineer can take that data and then make changes to the network to improve it, to optimize it, to fix a drop call area, to fix an area where sites aren't handing off to each other, that kind of thing. Another big one is the FCC dictates that carriers have to be able to do what's called an enhanced 911. You make a 911 call on your cell phone. It has to go to a certain call center. It has to pass information to that call center, including your GPS coordinates, where you're located, so they can dispatch first responders to the right place, because you don't have an address like your house, right? And so they have to go out and on a regular basis do that testing, to do test calls to make sure that that's all working correctly, routing correctly. Same sort of stuff is going to be happening inside the core network, the brains of the network. And that's getting into some of the work you guys do at Vertex with data center work, where you're doing maintenance on the electronics in the data center, right? So same sort of stuff has to be done there.
I'm not sure this is 100% true anymore, but I knew it was for a while. So I'll bring it up. To your point about the E911 testing, my understanding is that anytime there's a modification to a cell site in its antennas and broadcasting capabilities, you have to 911 test it before it comes back on air. Not sure if that's true, but I thought any kind of modification required that kind of testing to make sure it still works after, the modification is done. So just think about it. That's a lot. I mean, that's a lot of going out there and making sure that everything works repetitively.
Yep. And all of these things we're talking about, some of them are done, like I said, by employees of the carriers, cell site technicians that do some of it, data center technicians and engineers. And then a lot of it's outsourced. They hire companies like Vertex to do that work, right? Or Milo company. So yeah, that maintenance is definitely ongoing, always happens to every site in the network on some regular cadence. But I think what really drives this stuff more than anything in this work effort is making modifications to the existing network, which you kind of touched on, right?
Yeah.
I think cell sites, literally in my experience, almost every cell site's touched at least once a year in terms of some sort of modification being made to it. That's where I think the biggest amount of work effort happens in a life cycle of a network.
Yeah. So think about this. I had heard at one time that a cell site in the network itself from any major carrier, because of changes in technology and infrastructure and equipment, that it gets rebuilt in a sense or modified every 5 years. And so like technologies we were using 5 years ago, even simple things like coax and weatherproofing have now changed to fiber and something else. So that equates to, at one point, I'm throwing out some numbers here, but I think it's a cool one, that most of the big carriers, Verizon, AT&T, and now T-Mobile, do like 400,000 or 500,000 projects a year. And the majority being modification projects to the cell sites. Let's talk about that for a minute, Dan. This is the 5G guys. We know that the carriers are trying to catch up in deploying 5G. Give us an example of a modification for a 5G, for bringing 5G to a site. before it's full blown, the early phases.
Right. Well, first of all, before I go into those details, I think you're sort of touching on something that's a misnomer to the layman, which is that a lot of people think that 5G is the result of a bunch of new 5G sites being built, and that's not the case. It's existing cell sites being modified so that they become 5G capable. And so that touches on what you're asking. And so yeah, for 5G, there's really two major drivers for these modifications. One is new spectrum, so a new frequency band that the carriers acquired in some fashion through an acquisition of another company, through auctions with the FCC, what have you. And we talked about one of those that was big this last year, which was C band, which was a band of spectrum that sits right below the aircraft radar that had that big issue. So that's a brand new band of spectrum that the carriers that auctioned and bought that spectrum at auction from the FCC had to deploy at their sites. So that meant new antennas or replacing antennas with new antennas that could carry that frequency band. It meant new radios at the cell site, new electronics at the cell site that transmit and that new frequency band. So a combination of frequencies in that case. And then secondly, the technology itself. So from 4G to 5G is going to require new hardware, new software to be loaded to the site. So that's going to be new electronics for that. And then to support like the added bandwidth that that site might be carrying, you might have to upgrade the fiber to that site. So the fiber has enough capacity. So that might mean a new router. It might mean new strands of fiber. If it's microwave, it might mean an upgrade to the microwave radio and the microwave dishes. I mean, that all has to be done on every site in their network to get 5G deployed with across 100% of their network. It's a lot of work. And in fact, I can recall back in the years when, we were helping carriers upgrade from say 2G to 3G. And then now 4G's coming. So they're upgrading from 3G to 4G. And they still had sites in their network that hadn't been upgraded to 3G yet. And we're already moving on to 4G. Like you said, it's a repetitive, recurring thing to do these modifications for technology.
A cell site, over a period of years is a mix mash of technologies: 700, AWS, PCS, 850, CBRS, LAA, C-band. All of those technologies could exist at the same time or a variation of them on any particular site. And so, like how do we do a modification? Well, in order to get 5G to a certain part of wherever the cell site is in geolocation, it might just be to start out one antenna, and you still will be running the other legacy antenna. So it just gives you a good idea. And what happened? Modification triggers a lot of things. If you're talking about a tower, like you mentioned before, well, now you got to do a structural analysis on the tower because you're going to add a new type of antenna to it. And so it's kind of a snowball effect, right? Yeah, I want to go out and put 5G somewhere, and it's not a new site. So we got to make sure the tower or the rooftop mount holds the weight, and that we can also bring the right coax on there. So all these components go into a large modification process.
Right.
Kind of crazy when you think about all the technology being transmitted at one time from one location.
Yep. We've touched on obviously the physical work, which is very construction related, like the last episode we did. Talked a little bit about the engineering work that leads up to that. But when you guys run these kinds of projects, Wayne, what other trades are getting involved in this modification that we've talked about in the life cycle of these sites, right? We have these other folks involved, like SIDAC folks. Do they have to get involved with this stuff?
Yeah, it all depends. So we have to talk about the type of network. So if it's a REIT, real estate investment trust type network, like a Crown Castle or a American Tower, that's another component. They may own the physical tower that a carrier would go do the modification on. So you're now getting that group of people involved to do a modification on that site, which may be owned or leased by someone else. Other specialty contractors involved. To your point earlier, we're still upgrading every cell site with fiber. Not every cell site out there actually has fiber connectivity. Now, I think another maybe 5 years we'll complete that 10-year endeavor. I think we started fiber to the cell site probably 2014 heavy, and they're still, doing that. So you have those fiber providers that need to bring fiber and bandwidth to the cell site. You also have power, people who do power work and battery maintenance work, because to Dan's point earlier, I think there is some rules that a cell site has to have backup power and a generator. So, when you have a generator, they have to be cycled in maintenance pretty regularly to make sure they come on. I don't know what the cycle is these days, but it probably needs to run at least a certain amount of hours per month to make sure it works. And so there's a lot of different specialty contractors involved in doing the work. You mentioned system performance. Most of everything that's built on a tower is mechanically put together, meaning there's nuts and bolts. And over time, with wind load, and an antenna may lose its azimuth. And if you do, you'll start to have degradation of coverage in that location. And so not only do you have to have a contractor go check the antenna to make sure it's tight in the right azimuth, then you have to drive test it. So modifications take a big group of people. I don't know if that was really your answer to it, but it's a little bit more than what people think. Network assurance or operations, once a modification owns that asset. So they need to make sure that it's done to a quality, that it's integrated into the network. And so they have a big responsibility out there, the cell tech, the cell technicians for the carriers.
Right. And you talked about how a site gets refreshed, if you will, about once every 5 years. And, in my experience, when you start taking in those smaller changes, like an antenna down tilt changing because an engineer wants to optimize how that site covers because of the results of some call failure statistics or a drive test that shows an area that's not working well. Those kinds of smaller changes, like making an antenna change, those are happening, once a year. And so those are less sort of major, what I call forklift upgrades of the cell site. And that's the kind of stuff that in my experience, we would go look at sites every year. Like I said, rooftops being inspected every year to make sure that the signs for RF safety are intact and the doors locked, for example. So it's an ongoing effort. The other thing that's really big right now that a lot of people may not know about, and this goes back to, one of our early episodes. Remember Peter Thermos, when we talked about cybersecurity and the issue with Chinese espionage? And the whole issue was that some of the smaller carriers had deployed equipment from one of two Chinese companies, Huawei or ZTE. There's, upwards of 80 or 90 regional smaller carriers that people don't know about besides the Sprint, T-Mobile, and Verizon. And those guys had used a lot of this Chinese infrastructure. Well, we're now at a stage where Homeland Security and FCC stepped in and said, that stuff has to go away. And they're funding all of those carriers, ripping all of that electronics out and replacing it with non-Chinese vendors. That's getting ready to happen like any day. So those carriers are going to have a major forklift change where all of that electronics is ripped out and replaced with other electronics, which is going to cause an outage. So that has to be coordinated. And that's a major effort to rip all of that out. And it's called rip and replace, and minimize the outage to the subscribers when that happens. So that's a major effort getting ready to start. That is an example of the type of stuff you're talking about every 5 years.
Yeah. And, I think also in modifications, it is technology improvement. I think edge computing, right? Where a cell site, a lot of, folks may or may not know, but it was really built in a spoke and hub type of scenario in the past, where in the center you had a small switching or data center. And outside, you would have the spoke and wheel and hub type scenario where the cell site would be there. A lot of the edge computing now is done at the cell site. And so what does that mean? The routers that were sitting in a central office MSC data center are now being moved to the field, and they're getting closer to the end user. And I think some of the reasons you do that is like the frequency of how quick you buy, or if you stream your Netflix, it's a lot easier in that when it's closer to the end user. And so those also like inspire and generate tons of project modification works at a cell site, because technology continues to ramp up and get better.
Yep. I also remember over my career instances where we would do a similar rip and replace project across the entire network simply because of business terms. Like, we fell out of love with our partner that we were buying our equipment with, say Motorola back in the day, and wanted to rip all of the Motorola stuff out because of contract issues that two businesses couldn't agree on anymore, and replace it with, Ericsson or Nokia or whoever, so that doesn't happen very often, but that happens as well. And that's a major, major effort. That starts getting you some exposure to, the sausage making behind the business case these carriers have in terms of they're constantly spending money, constantly. It's a never ending capital effort, whether it's capital or expense, right?
Yeah, and and also just it's a big handout to like the general contractors who do this type of work. I mean, new construction is always easier to get there. When we talk about modifications to the cell site, we miss this super important component. These are live networks. People are doing their business, 911. And so when you have your team out there, they are actually operating on a live network. It's a tough role. And so my hats go off to the contractors who are getting it done without taking service offline, unplanned outages, because those guys are actually improving the site while also maintaining the site. And so when you get into that world, I mean, it takes a lot of skill, and my hats off goes to the technicians out there doing it.
Yeah, absolutely. In fact, to your point, they're often having to do this work in the middle of the night to help reduce the impact, right? So they're out there in the dark, cold, 3 o'clock in the morning doing this stuff. They're not doing it during the middle of the day.
Yeah, and so there's a reason that the tower climber profession was always ranked one of the top 10 dangerous jobs in America. I mean, technology and safety has improved. We use a lot of lifts, like you and I said, but it's still a really dangerous work working on a rooftop in the dark, being up on a man lift in the middle of the dark. But all great things to discuss, though. We could go on and on for hours, couldn't we?
I know. Yeah, for sure. But, hopefully this gives our listeners a good idea and a good picture of, in their mind's eye of what's happening to these networks and the life cycle. I think between the first two episodes in the series and this one, I think hopefully this gives our listeners a pretty good handle on like what happens in these networks and kind of how they get built and taken care of. Thanks for your thoughts on that. Obviously, with the work you guys do, project managing all this work, you guys have a good perspective on how this life cycle works.
Yeah, I mean, we're definitely a cradle to grave. And, I think one thing that we didn't talk about much here, but there's a lot of career opportunities for folks in the trades, and doing this kind of work, since it's such a broad swath of project management and site acquisition and RF engineering. And there's equipment engineering in there, and there's transport engineering when it comes to the fiber. And then you have implementation. There's a lot of good career paths for a lot of folks involved with modification of the network. We're just talking mainly in the wireless realms of network, not really, broadband or fiber networks and different things. So use this as a career opportunity. Hit Dan and us up. If we can help you, navigate that path for yourself, we're more than willing to try to help.
Absolutely. Yeah. As always, we love to have our listeners reach out to us with questions. We've been getting a lot more. So thanks for the outreach that we've been getting from folks with some really, really good questions. And to your point, Wayne, just a reminder on the careers, if you want to learn more about career opportunities, go back to episode 37. We had a great guest, Carrie Charles, who's within the staffing side of workforce development. And it's a great episode to learn more about career opportunities in cellular and in wireless. So thanks, man, for another great episode. Thanks to all the listeners for joining us. As always, hit us up at 5gguys.com to give us that feedback or find out more about what we got in the works. So Wayne, thanks for everything.
Thanks, Dan. Take care.
See you guys.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.